Let's begin with something familiar. How many ways can we arrange three distinct objects, say A, B, and C, in a row? We use the formula for permutations of three items. 3 factorial, written as 3 exclamation mark. That means 3 times 2 times 1 equals 6. So there are 6 different ways to arrange A, B, and C in a line. Now what if we were to arrange the same 3 items in a circle? Things will be different. In a circle, there's no fixed starting point. Relatively, the arrangements A, B, C, B, C, A, and C, A, B are all actually the same arrangement in a circle. Notice the relative positions of the objects. Let's say you are moving clockwise around a table. The order of the letters is the same, irrespective of where you start. This means that these 3 arrangements will be counted as 1. Now, in the anti-clockwise direction, ACB, CBA, and BAC are all the same arrangement, relatively speaking. So again, all 3 arrangements will be counted as 1. Remember, a circle does not have a starting point, so wherever you begin, the order is the same when moving counterclockwise. Notice the 3 objects have 3 seemingly different arrangements in the same direction around the circle, depending on where you start. But they are all the same arrangement, so to prevent overcounting, you need to divide by 3. So the 6 arrangements for the 3 objects when in a line is now reduced to just 2 unique arrangements when arranged around a circle. The same as 3 factorial divide by 3. To generalize, the number of unique circular arrangements for n distinct objects is n factorial over n, which can be rewritten as n minus 1 factorial. Why? Remember, the circle has no starting point, so we can view one item as being in a fixed position, and the rest of the objects are arranged around it. So in this case, we have 3 objects. So the number of circular permutations is 3 minus 1 factorial, which is 2 factorial, or 2. 4 married couples, that's 4 men and 4 women, are seated for dinner around a round table. In how many different ways can they be seated if A. There are no restrictions. B. Each couple must sit together. C. No 2 men are allowed to sit beside each other. Let's begin with part A. No restrictions at all. All 8 persons, 4 men and 4 women, can sit wherever they like around the table. Now, when arranging people around a circular table, we fix one person to eliminate equivalent rotations. That means we're really arranging the remaining 7 people in a circle. So we use the formula n-1 factorial. So, the number of ways to seat 8 people around a round table is 8 minus 1 factorial equals 7 factorial, which gives us 5,040 ways. Now, for part B, each couple must sit together. So instead of 8 individuals, we think of 4 blocks, 1 for each couple. First, we arrange the 4 couples around the circular table. Since the table is round, we fix 1 couple and arrange the remaining 3. 4 minus 1. Factorial equals 3 factorial equals 6 ways to arrange the couples. But within each couple, the man and woman can switch seats, meaning each couple has 2 internal arrangements. For 4 couples, that's 2 raised to the 4th power, which is 16 ways. So, the total number of seating arrangements is 3 factorial times 16 equals 6 times 16 equals 96 ways. In part C, no 2 men can sit next to each other. We need to ensure the 4 men are placed so that there's always at least 1 woman between any 2 of them. So we place the 4 women in alternating seats around the table. Let's fix 1 woman's position to account for the circular arrangement. That leaves us with 7 seats to work with. so we can arrange the remaining 3 women in 3 factorial ways. That's 6 ways. We now place 1 man in each of these 4 gaps between women. Since we're assigning 4 men to 4 specific positions, that's simply 4 factorial, or 24 ways. So, by the fundamental principle of counting, the total number of ways the group can be seated with no 2 men sitting beside each other is 3 factorial times 4 factorial equals 6 times 24 equals 144 ways. Here's another interesting problem. How many ways can you string together 5 unique beads to form a necklace? Number of arrangements in a circle is n-1 factorial. Remember that this includes the sum of both the clockwise and anti-clockwise arrangements. For example, A, B, C, D, E in clockwise order around a table is counted as a different arrangement to A, B, C, D, E in the anti-clockwise order around the table. However, if you flip the necklace, the clockwise arrangements of beads becomes anti-clockwise, unlike a table that cannot be flipped with legs up. So a clockwise and anti-clockwise arrangement of beads on the bracelet are the same, since the circular arrangement of beads has a mirror image that looks the same on a necklace. So, when finding the total number of arrangements of beads on a necklace, we need to divide by 2 to prevent overcounting. So, if n unique beads are on a circular necklace, they can be arranged in n-1 factorial ways over 2. Therefore, 5 different beads can be arranged on a circular necklace in 5-1 factorial ways over 2. That's 12 ways. Let's try one last problem. 10 students are to be divided into 2 teams at a meeting based on the available seats. Team 1 consists of 6 students to be seated around a circular table, and Team 2 consists of 4 students to be seated on a bench with 4 seats. Find the number of ways in which all students can be seated. To solve this problem, we need to choose which 6 students will sit at the circular table, seat them around the circular table, and seat the remaining 4 students on the bench. Let's first choose 6 students out of 10 for Team 1. That's 10 choose 6, which is 210 ways. For step 2, we need to arrange the 6 students around a circular table. For circular permutations, that's n-1 factorial. So 5 factorial, which is 120 ways. In step 4, we arrange the remaining 4 students on the bench. This is a linear arrangement, so n factorial, which is 4 factorial, or 24. We can use the fundamental principle of counting to get the total number of ways that all 3 events can occur together by multiplying the number of ways each event can occur by themselves. So, the total number of seating arrangements is equal to 210 times 120 times 24, which is 604,800. Hope you enjoyed this video. Thanks for watching. Remember to like, share, and subscribe. See you soon.